Alright, hopefully y'all can hear me. I'm actually gonna move this over here, and I'm just gonna go ahead and open up my OneNote so that y'all can see. Oops, I did that. So that y'all can see the live stream. I'm not sure why it's showing up like that. Let me, okay. Hopefully, I don't know if, make sure you guys, if it's blurry, make sure the live stream is at, what is it called? Make sure the live stream is at, like 720, like the, I forget what it's called, the graphics is at 720p and HD, so if it is blurry, I do apologize, just make sure it's at 720p. So, let me, I'm gonna just keep this open in case anybody joins. And okay, so hopefully that's good. I don't know if, hold on guys, let me make sure. I just need to make sure the live stream is playing right. Okay guys, let me go ahead and I'm just gonna go over here. Let me just turn this down. Just want to make sure it's playing at the correct like graphics or whatever that's called. All right. Okay guys, so we're gonna go over this problem. Actually, wait, I haven't copied it yet. Give me a second. So, we're just gonna do this problem, and this is the only problem I'm gonna do, so hopefully it doesn't take as long, but let's go ahead and do this. So, we're gonna, go over here, and just, let me copy the problem down. So we want to Okay, so we're gonna just go ahead and do this. Now, here, so we have the following, and it's gonna be the integral of, and it's gonna go the following way. So, dx over square root of 4x squared. I'm sorry, excuse me, no. 8x squared plus 1. And I think, if I'm correct, I'm just gonna... Okay. Now, this is the problem we have here. So, we're gonna go ahead and just evaluate this. Let me make sure that we're gonna go ahead and just... Okay. Now, let me copy this down. So, you know, I always write it down first. So we have the integral. And by the way, guys, happy Thanksgiving. I hope y'all have a wonderful Thanksgiving. And you'll eat a lot of turkey. So I know that, you know, I just hope everybody has a happy Thanksgiving with their families. And God bless you all. And thank you for watching. So we have this integral, and I had done it wrong the first time, but I pretty much got it. So we have dx over the square root of 8x squared plus 1. So let me just... square root of 8x squared plus 1. Just kind of... Right. Now, here, we're going to go ahead and just... So we're going to go ahead and just try to... So we're going to evaluate this integral, right? So, let me actually... Hold on, guys. Give me 1 second, everybody. So, hold on, everybody. I'm just gonna go over here and so with this integral, we want to make sure that we have to do by trig substitution. So this is one of those things that it is a very tedious method to do, but I am going to show y'all step by step how to do it. And I am going over this, and I know I've gone over some videos regarding this, but I just want to make sure that we understand it, because with Cal 2, it is very difficult. And that's why I'm always going over problems like these. So we're going to just go ahead and go over here and just and do this problem. So let's just get started. Now, the first thing we wanna notice is that this problem is of the following forms. So I'm just gonna, I might just turn my volume all the way down since I don't want there to be any sound playing off. So we're just gonna write the rule down. So one of the things is that we want to do so let me make sure and first write these rules down. So here we're gonna have the square root. So the square root of, and it's gonna be the following. I'm gonna say u squared plus a squared is equal to the following. And we're gonna do the following here. So hold on, guys. Sorry, everybody. So we're gonna do the following. Okay, guys. This is the following rule, and we want to say that this is where u equals a tan theta. Okay, so we're just gonna go ahead and do this. So u is a tan theta. So we have u is equal to a tan theta. And I'm gonna write down the I'm gonna draw the triangle right away because I didn't do it at the very beginning. I usually do it at the very end, but this time I'm gonna do it at the very beginning. Now, the way I'm gonna do this, we're gonna do the triangle in this following way. So we're just going to we're gonna do it in the following way. So so here we know that in this case u is 8x squared, or I'm sorry, u squared is 8x squared. We know that for sure, right? U squared is 8x squared, right? That is the first thing we must understand about this, okay? And so then here we're gonna just go ahead and do the following. So and then we know that obviously a, so we know that this is my u, right? And then my a value is the 1, right? So when I say that the square root of, and I'm gonna say 8x squared, and actually let me do it this way. So I'm just gonna kind of write it this way so that way we understand that this is like that, okay? And so here we're just gonna go ahead and do the following. So this is gonna be and we have the following going on. So it's going to be plus, so plus, and then we know that a squared is actually going to be 1, so I know that a squared is 1 because that is what is next to the plus a squared, which is obviously a constant, so it's going to be 1 for that. Okay. Now, now here, we're going to go ahead and just, so a squared is 1. So we know that when we solve for u squared as a, so when we solve for u and u squared, we're going to have the following. So u squared is equal to 8x squared, right? We need to solve for u. Okay. Now, when we do this, we're going to take the square root of both sides. So, oops. So it's going to look like this, right? And so here, we're just going to go ahead and do the following. So, we're going to have u is equal to, and remember that we have to go ahead and we have to go ahead and split it up into 2 different square roots, right? So we're going to go ahead and do that. Okay, guys, so we're going to have the square root of 8x, the square root of 8 times the square root of x squared, okay? And when we do the square root of 8, we want to understand that this is actually going to be the following, okay? So here, we're going to go ahead and do the following. So, remember that the square root of 8, we're going to have the square root of 4 times 2, just the square root of 4 times the square root of 2. And we know the square root of 4 is 2, right? So we have 2 square root 2, right? So it's going to be 2 square root 2 for that. So I know that u is, well, I know that is what square root of 8 is. And now the square root of x squared is just going to be x, okay? And so therefore, u is going to be 2x square root 2. So we're going to go ahead and put that in. Sorry, guys, hold on. Everybody give me 1 second. Okay. Now, here, so u is therefore 2x square root 2. So I know that that's what u is. And so I'm just going to state that. So u is 2x square root 2. And here, we're going to go ahead and do the following. So now we're going to put it in for the u squared there. Now, remember that we're going to follow this formula. So I'm going to rewrite it over here again. So u equals a tan theta. And actually, I'm going to go ahead and put it in the following way. So, so I know that that's what, that's how it looks. Now, here, we're going to go ahead and we're going to go ahead and just, plug in u, plug in a, and then plug in u as well. So we have 2x square root of 2 equals 1 times tan theta. Okay, guys. And now we're gonna have the following. So it's gonna be equal to the following. And let me just... And now if I know that this is on the right triangle, guys, let me move this over here. Okay. I'm gonna form the right triangle just using, you know, my theta, and so I know that theta is actually gonna be over here. So let me hold on, guys. Give me 1 second, everybody. So so here we have, here's my theta right here, and I know that, like I said, tan theta. So tan theta is gonna be 2x square root of 2 over 1. Okay, guys, because if we just divide by 1 here, you know, I know that obviously we can just put that, but since we're doing the right triangle, we must put it, you know, that way. And so here we're gonna have the following. So go back here and put that in. So like this, and then so I know that in my right triangle, I'm gonna just move it a little lower, and then okay. Now, like I was saying, so we have this, and so, if I do the following here, I'm gonna put, so obviously remember that from right triangle trigonometry, tan theta, so I'm just gonna quickly show y'all some right triangle trigonometry so that we understand, how this works. Remember that if I have, so here, if I have opposite here, adjacent here, and then my hypotenuse over here, I know that tan of theta is going to be my opposite over adjacent. Okay, guys, so we want to understand and make sure we understand our right triangle trigonometry here. Okay. So this is what we have. And then from here, we're just going to go ahead and just put this in for, so therefore my opposite side is going to be 2x square root 2. And my adjacent side is going to be 1. So we want to understand that we have to put it that way. Otherwise, you know, it's going to be, if we don't put it over 1 like that, it's going to be very difficult. Also, if you guys hear a dog barking, I do apologize. Okay. Anyways, we're gonna just simplify this, and so that we know that that is tan theta. And in our integral, we're gonna solve for x, okay, guys? So I know that 2x square root 2 is tan theta, so I'm gonna write that down again. Okay. And from here, we're just gonna go ahead and simplify this a little more. So we're going to solve for x. So my goal is to solve for x, okay? And then, so we're going to do that. So to solve for x, we're going to divide by 2 square root 2 on both sides. Oops. So x is going to be tan theta over 2 square root 2. So then here's the thing. I always like to rationalize. I feel like that's just the best thing to do here. So we're going to go ahead and do that. Now, here, we're just going to multiply by the conjugate, or the reciprocal, well, not the reciprocal. We're going to rationalize this. So multiply by the square root of 2 on top and bottom. And so we have, this is going to be the square root of 2 tan theta. And obviously these two just become a 2 like that. So it's going to be over 2 times 2, which is really equal to the square root of 2 tan theta. Oops. All over 2. Okay, hold on, guys. I'm just gonna do something really quickly. Hopefully, 1 second, guys. I don't know if I can change the, oh crap, I guess I can't. Okay, that's fine. So, it's gonna be over 4, okay? Now, here, hold on, guys. Now here, we're gonna just put this in. So we know, again, x is square root of 2 tan theta all over 4. Okay. And so here, we're just gonna go ahead and put this in. So I'm gonna, obviously I'm gonna rewrite it here. So thus, the integral of dx over the square root of 8x squared plus 1 equals, and we're going to just kind of do this, okay? So it's going to go like this, the integral of the following, it's going to be dx over, it's going to be the square root of, give me a second, guys. It's going to go the following way, and I'm just going to try to, first I'm going to go ahead and just write down the formula. So 8, and then for my x value, again, here, we know that x, again, I'm just going to write it down one more time, is square root of 2 tan theta all over 4. I know it's right here, but let me just lower it down a little bit. Okay. So here, we're going to just go ahead and do dx over the square root of 8, and I'm going to put the square root in a minute, so it's going to go 8 times the square root of 2 tan theta all over 4. And then this is squared, and then plus 1. So again, guys, I'm just going to that's fine. And so then, and we now we need to find dx, okay, guys? So we know x was, again, I'm just going to copy it down, so I know it's a lot of copying, but I'm going to do it a little separately here. Let me go ahead and find dx for this. So I'm going to go ahead and find dx. Here, we're going to just go ahead and do this. So we have so dx is equal to the square root of 2 over 4 times d dx of tan theta. Now, we want to understand that the derivative of tan theta is, I believe it's going to be secant squared, if I'm correct. Yeah. So remember that this part is secant squared. So therefore dx is going to be square root of 2 over 4 times, and it's going to be secant squared of theta d theta. You want to make sure you put the d theta part, because if you don't do that, it's, you have to make it in terms of with respect to theta. Okay, everything is going to turn to theta. So I know that dx therefore is going to be square root of 2 over 4 secant squared theta d theta. Okay. Now, here we're gonna go ahead and do the following. So, now, so we're gonna plug this in for this. So this is what's gonna go in. So again, I'm just gonna write it down over here. I know it's a lot of writing down over and over, guys, but I'm doing this for a reason. Actually do it. So this stuff here is going to go in for this. Now, we're going to go ahead and just do the following. So we have the integral of dx over the square root of 8x squared like that is going to be equal to, it's going to be, so we're going to put this in for the top, so it's going to go the following way. The square root of 2 over 4 and then secant square root of theta, and then hold on, guys. So the square root of 2 over 4 secant square root of theta. And then over, oh, and d theta, right? So just make sure to put that d theta up there. So here, just put that d theta there, over, and it's going to be 8 times the quantity, and we're going to put, I'm sorry, I forgot to put this entire thing in terms of the square root. So as a square root, right? I forgot to do that. So we're going to have the following. 8 times, and now we need to simplify this. So really, if I square this stuff here, I know that's hard to see, but if I square that stuff there, we're going to have 2 tan square root of theta over 16, and then plus 1. Okay, guys? So we have the following. So here it's going to be, and now this is where it gets interesting. So I'm gonna put this as an integral of 2 fractions divided. So I'm just gonna state the following. Let's see here. It's gonna be the square root of 2 over 4 secant square root of theta. And then I know that on the top it says d theta, but the entire thing is with respect to theta, right? I mean, if you think about it. Okay. And then divided by the square root of 8. And this part here, guys, it's gonna be times 2 over 16 times tan square root of theta. And we want to understand, do not, like, we're not, like, simplifying, like, you don't want to distribute to the tan square root of theta plus 1. It's going to be like this. So you just be very careful with the algebra there. And then with respect to theta, right? So this entire thing with respect to theta. We can simplify this a little more. So I do think that it, you know, the square root of 2 over 4 can be taken out. So let me think here. So I'm going to take out the square root of 2 over 4 because remember that the constant times times the integral of a function is really, or the integral of a constant times a function is really the constant times the integral of that function. So this is just the idea that, you know, this is the rule here for why I'm doing this. So the integral of c f of x. So let me just kind of write this rule down really quick, guys, in case y'all don't remember. Of c is equal to c times the integral of f of x. And I forgot to put the dx there. So hold on, guys. Is equal to c integral of f of x dx. Okay, I mean, it is in terms of theta, but it's kind of the same idea here. We're just taking out that square root of 2 over 4. So thus we have the square root of 2 over 4. And then we're going to put integral. And actually, you know what? Actually, we're not going to take out the constant yet. I don't want to do that yet because I don't want to mess this up. I really don't. I'm not 100% sure because I don't think the square root of 2 over 4 is being... I think you can do it, but just to be safe, we're just going to leave it there. Because I can't remember if you can or not, if you can take it out. So we're just going to leave it as it is. Square root of 2 over 4, secant square root of theta, and then divided by, and it's going to be the square root of, it's going to be the square root of 1 plus, or I'm sorry, tan squared of theta plus 1. Because if you think about it, 8 times 2 over 16, that becomes just 1, and then tan squared of theta plus 1, so, and then this entire thing is with respect to theta. Okay. Now, this is where it gets interesting. So, we're going to have the following, and actually, give me a second, guys. Give me 1 second. Okay, so it's going to be the integral of the square root of 2 over 4 secant square root of theta, and we're gonna, it's divided by secant square root of theta. Square root. Because remember that from the Pythagorean identity is, I'm just gonna do the rule is that tan squared of theta plus 1 equals secant squared of theta. So that is just a little bit of from calculus, or from pre-cal, excuse me. So we're going to go ahead and do that. Now, doing this, we're going to have we're going to put that in for the secant squared, or we're going to, that's basically what I did there. Now, this is going to be the integral of the square root of 2 over 4 secant square root of theta, and this is going to be equal to the following. So it's going to be times, and actually divided by this, divided by secant theta. Now, obviously, when we do this, remember that a divided by b, we can write it as a fraction a over b, right? So this really becomes, we're going to do the square root of 2, integral of square root of 2 secant square root of theta over 4 secant of theta, because the secant of theta goes on the bottom, right? And actually, I'm just going to do the rule. You're going to take square root of 2 secant square root of theta over 4, and then you're going to multiply times 1 over secant theta. Oops. Sorry, I didn't write that correctly. Okay. Remember, a over b divided by c over d is a over b times d over c. You're just going to do keep it, change it, flip it for that. All right. Now, here, we're going to have the following. So let's see. It's going to go the square root of 2 times secant of theta times secant of theta, because that is what this part is. I know I'm doing a lot of algebra here, guys. It's just for those of you that do not understand how to do this. So, oops. If you don't know your algebra, that's what I'm doing here. So, it's going to be, and I forgot to put this with respect to theta. So this is the square root of 2, the integral of the square root of 2 secant theta times secant theta all over 4. Secant theta. Okay. Oops. Now, here, we're going to have, so the secant theta will cancel out, right? So that we're just going to have the integral, oh, and d theta, right? Forgot to put that in. The integral of square root of 2 secant theta all over 4 d theta. Now, this is where it gets interesting, okay, guys? We want to use a very special formula for this, where we're basically doing, the following. So, the square root of, so we're going to take that square root of 2 over 4 out, times the integral of secant of theta. I can never write correctly, guys. I'm sorry. Okay. Now remember that the rule goes, this is the antiderivative of secant theta. It's going to be equal to, and this is where I actually did it. So the natural log of the absolute value of secant theta plus tangent of theta, and then plus my constant of integration, c. And then from here, we're just going to go ahead and put, so it's going to be the square root of 2 over 4 times the quantity, the natural log of secant theta plus tangent of theta. Plus my constant of integration, c. Now, there are a few more things we have to do, because we have found our antiderivative. However, you want to convert it back to algebraic expressions. This is where the right triangle comes in. Now, obviously, if you do Pythagorean theorem in here, you don't have to do that, but you have to remember that our original integral whatever square root was at the bottom is for it goes for the hypotenuse. So I just want to make that clear that whatever of our integrand, meaning the integrand meaning like what we're integrating. Is our hypotenuse. Okay, so we know that that is going to be the hypotenuse, so therefore we know that if that is true, then you can always do Pythagorean theorem if you're not sure, but just remember that it's whatever is on the bottom of the square root, or on the bottom of the expression, the square root at the bottom, right? So we know that this part is going to be the square root of 8x squared plus 1. Now, if I just copy and paste this, I'm just going to copy and paste it wherever I was doing my work at the very bottom. And I do apologize, guys, this problem is so long, but I really want to make sure that we know how to do these. They are very difficult. They're very lengthy. So I understand if it is overwhelming because these are very difficult. But bear with me. That's why when I do videos like these, I skip a lot of the, when I do the writing, I do skip a lot of the pausing and everything. Now, here, we're gonna do the following. So, it's gonna go, so we know that we need to find secant theta, okay? Secant theta, every time I write the C, I always put it as a parentheses, is really, remember from right triangle trigonometry, it is really going to be it's really going to be the following. Adjacent, so hypotenuse over adjacent, really. So it's going to go H over A. Okay, and we know that my hypotenuse is square root of 8x squared plus 1. So we know that that is the hypotenuse. So we're just going to put that in there. Over my adjacent, which is just 1, right? Okay. And then, so that is what goes in for that. So I know that secant theta, therefore, is equal to the square root of 8x squared plus 1. We don't have to put the over 1 for that because, again, we're just putting it in for the final answer there. Now, we're going to go ahead and just finally just put that in for that. And now we need to find tan theta. So this is the final step here. Tan theta, remember that tan theta from right triangle trigonometry, it is really opposite over adjacent. So really, it's going to go opposite over adjacent. Okay. Now, here we're just going to put it's going to be the square, I'm sorry, 2x squared root of 2, and then all over 1. So I know that obviously tan theta is just 2x squared root of 2. So I'm just going to put that in there. If y'all hear like background noise, I do apologize. They're always playing music. This is what's going to go in for this part. So therefore, and remember that we are doing the square root of 2 over 4 on the very outside of this. And so we're going to just say that this is equal to, so it's going to be the square root of 2 over 4 ln, so ln, or natural log, of the absolute value of, and remember secant theta was the 8x squared plus, square root of 8x squared plus 1. So again, I'm just going to highlight that here. So this was secant theta. And so we're going to put that in for that. So we have ln of 8x squared, square root of 8x squared plus 1. Plus, and it was tangent of theta, which was plus 2x squared root 2. And then close the absolute value, and then finally put the plus constant of integration c. And therefore, the integral, therefore, we're just going to write our final answer, and it'll be perfect. The integral of dx over the square root of 4x squared, I'm sorry, 8x squared plus 1, excuse me, is equal to the square root of 2 natural log of the absolute value of the square root of 4x squared plus 1. I keep putting 4x squared plus 1. 8x squared plus 1. And then plus 2x square root of 2, close absolute value, plus c. And this part is just all over 4. And that, guys, is the final answer for this problem. This is the final answer for this problem. So that is going to be it for this live stream, guys. I wanted to do a live stream for this because these problems are so long and it's going to take me forever to edit it. So, and also to post it, etc. And I just don't have the time. So, I hope that helped, guys. And thank you so much for watching. And again, I hope everybody has a happy Thanksgiving. If anybody has questions about this, let me know. And please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.